So today I'm here to talk about building an army of Mac admins. So let me start introducing myself first. So my name's Greg, and I work on the CP team at Facebook. I've been there for about 4 years now. I joined right before we switched from, a closed source management tool to our open source stack, which is Chef, Chef, Monkey, and a few other things. My claim to fame is I built some of the things for Monkey, like application usage and removals and the banners. Never open sourced it, but we used it at Facebook for the last 4 years. Right now I'm at a Mac conference, but mostly last 6 months I've done mostly Windows and Linux support, but I have supported Macs in the past. So when I first submitted my proposal for this talk, my title was Building an Army of Mac Admins. But as I reflect back on that, I'm not a Mac admin, I'm a client admin. I manage Macs, Windows, and Linux. On top of that, we do mobile support, but I'm not going to talk about that in this talk. So today, what I'm going to talk about is not only how do we empower people with our team to do more, to be better at managing our clients, but how do we get external people, right? Not just help desk and your IT support staff. I'm talking about our external developers. I'm talking about our security teams. I'm talking about our field techs, and I'm talking about our WhatsApp and our Oculus teams to contribute back to our client platform. And so one good example of this is something called boot camp. So every new engineer that comes into our company goes through a 6-week boot camp course. And what it is you get a laptop, you get a series of tasks, bug fixes, feature requests, anything you want, you can work on it. And a lot of the tools are self-service. So you don't have to go to another team and say, hey, can you do this for me? You have access to do anything you want. So that is where we want to be. And today I'm going to talk about how we are making Chef, Puppet, Chocolatey, and App self-serviced. So just a little rundown. I don't have exact numbers about how large our fleet is. It's in the thousands. But it's roughly 75% Mac, 24% Windows, and 1% Linux. In terms of Linux, we support basically every distro. So that's Ubuntu, Debian. We support Fedora, and we support Arch. By support, I loosely say we support it. It works with Chef, that's all I can say. In terms of the tools that we use Chef for all platforms, and that's for configuration management. We use Monkey as a package manager on the Macs. We use Chocolatey as our package manager on Windows. And we support apt, Yum, and Pacman. It's Debian, Raw, and Arch. So let me talk about source control. Who here uses source control? Good, a lot more than I thought. So source control is great because it gives us a tool that anybody can use to contribute back to our tools. And that works well for the most part if it's text files, but what about binaries? Who's controlling their Monkey repo with Git? Yeah, very few people, right? And I'm assuming some of you guys use GitFat? No? Yeah. So we used GitFat for years. It worked well when we were a small team and a few people were contributing to our repos. But as we started to scale, we started to realize that GitFat doesn't really work, right? Our repos were becoming gigs in size, and it wasn't feasible for an external person to clone our entire repo, especially since our default Mac is 256 gigs. So therefore, our repos wouldn't even fit on their client devices. So I rewrote GitFat internally using a lot of our internal tools, and it does basically the same thing GitFat does, but a little better. We can do sparse checkouts, so you can say, we call it pantry. You do a pantry retrieve, and you can retrieve either the individual repo you want, like a Yum repo or a Monkey repo, or you can retrieve all. And some of the best things, I'll go over in a second. But yeah, we had to rewrite GitFat. Unfortunately, I can't stand here and say it's open sourced, and I don't think it ever will be because we depend so much on our internal tools. So with that said, I'm going to start talking about config management. So like I said earlier, we use Chef. So the first thing we do to allow people to contribute back to our tools is we write API cookbooks. And I'm not going to go into too much detail about what API cookbooks and a lot about Chef because my coworker after this is going to give a talk about Chef. But essentially what an API cookbook is it's a cookbook to manage either a system setting or a system service or an application, and you can determine the behavior of it by setting key value pairs. Some examples are like Bluetooth, screensavers, power settings, Monkey, Chrome. You can all do that with very little coding. So let me give you some examples. This is if in your configuration, if you wanted to set, add something to your search path, you would update the CP pathsd attribute with whatever you want. And so any machine that has that settings now will have that path in their search path. Simple, right? The next thing is like Spotlight. Let's say you don't want Spotlight to index some large Git repo you have or something like that. You can exclude it by updating this attribute. And so on. So this is our Splunk, right? End users don't need to know how to configure Splunk or where the path is for the Splunk configs. They set up an attribute. They say, this is the app I wanted to be indexed with Splunk. Here's the index, here's the source type. And we compile that all, and we write the config at the end of the run. So again, no coding involved. It's somewhat easy. So here's another one. This is for our Windows, right? This would normally be done with a GPO, but GPOs, you have to restrict access a lot of times. It's not really source controlled. So we wrote a API cookbook to set the audit policies. And these are just like, we want to know that every time there's a successful like removable storage added, it logs it to the event viewer, which gets pumped to other tools, and now we can see who's doing what. And again, you set 2 values. And lastly, this is like for Linux side. If you want to change your kernel settings, you can essentially update the value one, or the key and the value, and we'll write it at the end, and you don't have to do any coding around that. And so to prove that how easy it is, this is, I apologize, you probably can't see it. This is the code to manage our dashboards. And those are obviously the machines that are put on the wall, people post, like put their metrics up. And we configure that entire client, which is API cookbooks. So for example, you guys can't see it, sorry. But that right there disables the screensaver. That right there disables the Bluetooth keyboard prompts. Right here, we set power management settings, so we want it to wake on WAN. If it gets rebooted, start, or if it gets shut down, restarted. This right here sets our monkey settings, so we say it goes to the dashboard client manifest. We also say that we want Google Chrome and we want Firefox on those machines. Yeah. And then this one right here says disable Duo, which is our 2-FACT tool that we use, because those machines are in a rat hole VPN or VLAN, and therefore they don't have access to the web. Therefore, they don't have access to our Duo endpoints, so it's not needed. And lastly, this is the API cookbooks to set our firewall config. So we say only allow SSH access to that box from these jump hosts. Again, fairly simple, very little work that the end user has to do. They just set a bunch of values, test it, and then they can deploy it. The next thing that we kind of do is called node customizations. We set some default values that we think all end users should have, but in the event that a user doesn't like, say, settings that were pushed, they can come along and update it if they want. Again, using nothing but API cookbooks. In this case, I'm actually taking exact examples of some settings that people said. In this case, this guy said he doesn't want Chrome extensions on his machine, so he sets the attribute to a nil array. Therefore, no Chrome extensions get applied to his machine. This person right here said that Outlook was hijacking his Mail.to, and so therefore he set it so that he deletes it as a manage install, and then he sets it as a manage uninstall. So what happens is we'll never install Outlook on his machine, and since it was installed, it will remove it. Again, a couple lines of key value pairs, and the end user had the machine set up how he wanted. This person who has a Linux machine, he sets his cron to run upgrade on his machine every day at 6:35 a.m. Right? He's a sadist. I don't know why. But again, it's his choice. He gets to manage his machine how he wants to, and we get insight to know like what our end users like and don't like. And lastly, this is kind of my favorite. This guy sets his Etsy host to localhost for Reddit and Hacker News because supposedly he doesn't like distracting sites on his laptop. The next thing is helper libraries, right? Anytime we see like redundant code, so maybe people are reproducing code within our chef cookbooks, we'll write helper libraries. And these can be like GET requests to our internal stack. Like what Facebook group do I belong to? What site var do I need to retrieve? Shard over a week, which allows you to roll a package out. It goes 1, 5, 10, 15, and so on. And so we write a bunch of those. Again, the reason why we do this is to make it easier for the end user to help us manage our fleet. So next thing that we do is package management. And I'm going to talk about Monkey. So I think everyone has already everyone here understands how great Monkey is. Yeah, should give a clap for Nigel, yeah. Yeah, so honestly, it makes our job a lot easier. So out of all the package managers I use, Monkey is definitely the best and the easiest to use. And it's amazing how well built it is considering some of the other tools that we use. So we do Monkey slightly different at Facebook. First of all, everything's local only manifest. And why we do that is because now we can have all the config in Chef versus having a manifest for these applications, and we have all of our configuration settings in Chef. Now we can look in Chef and we know that we have all these settings set and we install this application. So again, I think I already showed you a few examples, but in this case, we set our API cookbook to say we want Google Chrome as a manage install. Chef will apply that. Monkey will run next time and install Google Chrome or force it to be installed. You can do the same thing with manage uninstalls. The next thing we do is we make the catalog server-side. So we don't do client-side make catalogs. And what this allows us to do is someone can use our internal repos. They can import one package, right? And because make catalogs depends on the icons to be present to hash, they would basically have to have the entire Monkey repo checked out. By making the catalog server-side, they don't need to do that because we have the icons hosted server-side. Make catalogs will just work. And what this also allows us to do is again, no one needs the entire Monkey repo checked out. They can just import one file or one package. Next thing that we do, which is kind of cool, using the same process that makes catalog server-side, we have fake catalogs, right? And so the way this works is if a pkginfo file has a catalog called autopromote, which doesn't exist, right? It's a fake one. What we do is we look at the creation time of that pkginfo, and then we can start rolling that package out dynamically. And so let me give you some examples. If a package has the catalog autopromote, the first thing it might do is be pushed to a CPE catalog, which everyone in CPE is pointed to. It might sit there for 24 hours, 48. We could set the value if needed, or whenever we set the value to whatever we want. And the next thing it does is it says, oh, hey, that package has been sitting in CPE for X number of hours. Now I'm going to automatically promote it to test group, right? Might sit there 48 hours, depending on how long you want it to sit there. And then we have some monitoring around that. We do some communication to our test group. They report back whether something works or not. The next thing it will do is it will push it to everybody. So again, one person adds that fake catalog to the pkginfo files. We build the catalogs dynamically on server side, and we roll it out to our whole fleet, right? Previously, it would probably take one person doing multiple diffs. In this case, it's one process. It's simple and it's streamlined. The next thing we have is we have another catalog called autopromote slow roll. So we deal with a large number of clients, and we have to build our internal, our distribution servers are all built internally. And there's some updates like Outlook, the Office updates, they're a gig each. That's 4 gigs, potentially to 10,000 clients in 1 hour. And that can burn our WANs up in the local offices. So what we do is we do something called a slow roll. So if this autopromote slow roll catalog is present, what happens is it pushes to 10%. 4 hours later, it will go to 20%. 4 hours later, it will go to 30 and so on until it reaches 100%. And what that does is it allows us to slowly roll our package out without burning up our WANs or overloading our distribution points. And again, the reason why we're all trying to build all this logic is because we want to make it easier for our end users to support our tools, or to help us support our tools. So, God, the graphics sucks. So again, here's an example of our actual Fabricator tool, which we use for peer review. Again, here we are rolling out VMware Fusion 855. This right here, where the arrow's pointing, that just shows that's a representation of the binary itself. It contains checksum file size and modified, and that's what we use as a replacement for get fat. And then here is the pkginfo file that contains the pseudo catalog called autopromote. And again, if that's present, it will slowly roll it out across our fleet over a course of a week. Yeah, so that's the few things we do with Monkey that are slightly different than what most people do. So the next thing we use is Chocolatey for Windows package management. If you're familiar with Windows, there's other ones out there. We chose Chocolatey because it's somewhat decent, and there's a large community of already pre-built packages. So essentially what a Chocolatey package is it contains, I didn't build it, but anyways, the Chocolatey package contains a new spec, which is very similar to a pkginfo. It contains a bunch of metadata like, version, title, dependencies, stuff like that. It has a tools directory. In the tools directory, you actually write some PowerShell script or code to tell Chocolatey how to install and how to uninstall. And then, of course, it comes with a package installer. So we don't technically do anything different, for example, but that right there, this new spec and all the tools are code, right? So the default behavior is you would build this Chocolatey package, which is similar to a zip, and you would push that to your Chocolatey repos. What we do something a little different in the sense that we require all our end users to check in the code itself, and we will build the Chocolatey package ourselves and push it to the repo. We have a back-end process for that. And so here's a perfect example of someone who pushed, what was this? IRB, right? So you have the new spec, like I was saying, it was just a bunch of metadata. You have the install script. I blurred out the URL it's pulling from. And again, the representation of the binary. That gets checked in, gets diffed, we review it. Once it's reviewed, it gets landed, and then on the server side, we do all the matches, compact it, push it to the proper feeds, and then our clients can install it. The next thing we do is we manage multiple Linux repos. The way our Linux the way we have our Linux environment set up is that we rely on our community to support themselves, right? We don't do much of the management or the managing of them. So what that means is our repos need to be self-serviced, right? So whenever, say, the new Ubuntu 17.10 comes out, I don't want to be the person who has to know that it came out, create a new repo for them, add all the necessary packages. So what we do is we essentially have a config file that they add the new repo. You add the version and the code name to it, and then we use Apply on the back end to build that repo dynamically. And what we also do is we have a series of directories. So for example, if you drop a package into any, or Ubuntu ND, or the specific version, what would happen is if 17.10 came along, we would add all of the binaries in any and Ubuntu any, and then additionally we'll add the binaries for the 17.10 version. And it works fairly good, or works pretty well, and the users don't rely on us to do a lot of the management around the repos. The next thing we get a lot of requests for is metrics, right? People want to know who has what installed, how many people have that application installed, how many people have used that application in the last 30 days. And our security team wants to know, like, hey, that patch you pushed, how many machines have got that patch? So we do a bunch of stuff with OS Query. We pull metrics from Chef, we pull metrics from Monkey, and we use Splunk, and we have some internal tools that we use. And what we do is we build this kind of giant pipeline, takes the data, extracts it, manipulates it a little bit, compacts it back, and then now what we can do is we can have application lookups. So in this case, you can look up who has Firefox installed based on the app name or the bundle identifier. And I blurred out the install numbers, but this is just a table showing the version and the installs. You can do a bunch of other stuff to get aggregates over time. You can just get one total count. And I know I use Firefox as an example, but the perfect example would be Outlook, right? When we do Microsoft true-ups, our logistics team can come in here, run some data, run some queries, and then now they can easily understand how many installs are on our clients for Windows and Linux. So the next thing is how many people you remember a couple weeks ago when Microsoft, was it Defender? No, the engine, the malware. No, not Samba. The what's the antivirus on Windows? Windows Defender. Yes, there you go. So there was a big vulnerability 3 weeks ago, right? And instead of our security team coming to us saying, "Hey, how many people have got this patched?" They can just run a query, right? They can see that on Wednesday, May 10th, it started getting installed. You see the drop-offs by the end of the day, but by the end of the week, a majority of our fleet had it installed. And they're not coming to me to get that data. They're going to get it themselves. The next thing is imaging. I know Mac imaging is supposedly dead, but Windows imaging is not. So, like, I don't know if you guys have heard this, but Facebook owns Oculus. They do a lot of testing around consumer hardware. As a team, we can't really support Oculus in terms of being able to image every single one of those devices, right? We have a set of hardware that we support, that we know the drivers work. We support that. We're building a framework right now so that the Oculus support team can, whenever they go out and they buy these hardware, they can contribute back to our Windows image and add the drivers, right? Again, what we're trying to do here is reduce the amount of work on our team and put it onto other people who are the subject matter experts, and therefore, both people are happy, both teams are happy. Lastly, not everything is sunshine and rainbows, right? Like, people come to us and say, "I need this now," right? I don't have the time. Most people on my team don't really have the time. And so there's a lot of pushback. They go complain, they cry to their managers. They tell us they don't have enough time to do X, Y, and Z, right? But they can. They just don't want to. So we have to deal with a lot of politics around that. Again, some people are not technical enough to run this. So again, we have to, weigh the pros and cons. Sometimes we have to do the work for them. The other thing is Facebook's very critical about tools not being good. So a lot of the prod developers who have to use our tools, like when we first started, bitched to us, right? They would complain, they would make nasty posts. Again, we open up ourselves to criticism. Again, it makes us better, but you still have to fight off some of the criticisms. The other thing is you'll find that people will find unique ways to break your infrastructure, right? Stuff that you did not account for, people will figure out how to break it. Again, you'll also find out people will find certain ways to use your tools to do things that you didn't imagine, right? So it's not perfect, but we're getting there. We're working hard on it. And in terms of some of the successes we had, so in the past, security used to come to us and say, "Hey, we need this implemented, right? We know there's a vulnerability, we need you to push this." Or, "We need this tool built because it will make our security footprint a little better." But now we have a partnership with security, right? We work with them to build our roadmaps. If we don't have time to build that tool, a lot of times they do. So they take on that workload. So some of the examples of what security has built for us is they built an admin and encryption key escrow, and it's built on our internal stack. And it's awesome in the sense that anybody in our company can look up an admin password or a file, not anybody, but it's most anybody, can look up an admin password or an encryption key. And what we do is the next time Chef checks in, it says, "Oh, that key has been accessed or viewed," and we will rotate it, right? So it allows people to get those important information, but it also allows us to rotate it when needed, and they built that for us. They have also built us an always-on VPN so that we do have some kind of back door. Whenever there is a critical vulnerability, we can push a patch if needed. The other thing is I think, 6 weeks ago, there was a LastPass vulnerability, right? There was it was somewhat huge, and we use LastPass for our package manager. Password, sorry. And so we didn't do any of that work. Security did all that work to make sure that LastPass extension was removed from all machines. Then they worked with LastPass to make sure it was patched, verified it was patched, and then re-enabled that extension on all our machines. Again, we didn't really do much effort. They did consult. They did come to us and ask us a few questions, but again, we didn't do a lot of work on our side. So the other thing is we have a lot of internal devs who build tools that improve the efficiency of our other devs, right? This is we have our Xcode environment, our Android environment, OS Query, for example. We have our own custom IDEs. We have forked versions of Mercurial and Git. Again, we do not deploy any of that. They build their tools, they push their tools, they communicate to the community when they're pushing it, and when something breaks, they're responsible for fixing it. Little less, or not as much work's put on us. The next thing is Linux support. We officially only support Ubuntu LTS, and I did a base management setup of it, but another guy came along who was happy to do some of the work with me, and he built 60% of the configuration. Again, my team didn't do any work. Others have come along and added Arch support and Fedora support. And lastly, we own WhatsApp and Oculus. They have different requirements. So they can come along, change our code, or change whatever settings we have set for the clients to fit their needs. Again, we don't do the work. I'm not trying to say we're trying to push off the work. We are somewhat a small team, right? I talked to someone earlier that said they have 40 people doing the level of work that we do with 7, right? We can't support that level of scale without having other people do the work for us. And again, I'm not bullshitting you when I say that other people are contributing to our tools. This right here, I just did a simple Git log, and I grabbed a bunch of metrics. The green line is the number of commits over time. The blue line is the number of unique contributors over time. And right at that point is where we opened up our tools to be used by external people. And you can see it skyrocketed, right? It's probably, it's quadruple? No, 10 times growth in the last 6 months. And lastly, if you wasn't paying attention, and the one thing you take away from this talk is that if you just change your workflow slightly and you try to encourage other people to manage, help you manage your tools, they will do it, right? There's some people that don't want to, but there's other people that are eager, right? They want to own their whole stack. So build the tools, let them manage yourself, or let them help you manage your own tools. And lastly, that's it. Questions? Whew, got it over with.
Thank you so much. Oh, question. Oh. No questions? Okay, Clay?
So I like all of the ability that you give the users to customize their own environments, doing their own things. But how are you worried? Are you worried about them doing things to accidentally or intentionally break your tools by giving them the ability to manage things?
All our clients have root access on their machines, right?
Right.
So what would happen in the past if they didn't like what we were doing? They were just wiping our management tools. This at least is a better solution. If they don't like what we're doing, they can commit a diff saying, hey, this is what I don't want. At least we know that they disabled X, Y, and Z.
Right.
But we still have those machines managed.
Okay.
So
we have proof.
We have proof, yeah.
Security audits those changes.
Yeah.
Excuse me, what? Sorry?
And our security team is included in the diffs that you're making, so if you do something stupid, they'll be like, hey, what are you doing?
Yeah.
Questions?
There's a couple in the back.
Can you guys move forward? Hey, Jeff, can you pass
Hey, I'm not sure if you mentioned, but do you work in some kind of PCI or SOX type environment?
I'm sorry, repeat that?
Do you work in maybe a PCI or a SOX type environment, like where you get audited quarterly or yearly?
It's really bad echo up here. You're talking about PCI?
Yeah, do you work in a PCI environment?
Oh, yes.
Okay, and how do the auditors feel about?
Be honest with you, we don't deal with the auditors. Another team does it. I've never. Yeah, maybe he can count for it, but I've never actually interacted with auditors. I know we do have a team that does that, and they reach out to us when they have questions, but none of them said they don't like what we're doing. So.
Oh, thanks. Fair enough.
Yeah.
Thank you. Hello, yes, it is a question. Thank you very much. I have no idea how your auto-promote or your auto-promote slow roll catalog interactions work. You may not be the best person on your team to answer that, but what's where and how? Because that's really interesting.
Okay, so essentially, if you look at the PKG info file, there's a metadata location, right? We'll inject a creation date in that.
None of this sounds like plist or where's the
PKG
server or there's moving parts involved, right? That there's, I think of a catalog folder on a plain bucket on a server, right?
Yeah.
Where does the auto promote plist fake? Does it really not exist as an XML file on that same server?
The auto promote catalog does not exist at all. It's a fake catalog. What we do is we check in the PKG info file with the fake catalog present, and then what we do is we just take that catalog, that PKG info file, and we just remove auto promote and add CP to it, and then we make the catalogs, right? So we have.
Oh, okay, so you have a server-side function that acts on looking for that label, essentially.
Yep, and then it will rebuild that if we need to, based upon time and all that stuff, and then we make the catalogs, and that's how it gets pushed to all clients. Nick McSpadden, we came up with the idea as a team, but Nick McSpadden wrote it. I think he wants to open source it. Hey, ping him, bug him about it.
He would love me for asking that too, I'm sure.
Yeah, yeah, everyone. Just everyone
Thank you.
asking Slack, Nick, what's up with this auto promote? There's someone in the back, but. We good?
Yeah, you mentioned imaging on Windows. What do you guys use for imaging there?
We use MDT right now.
Oh, okay. And do
Yeah.
you do zero touch or light touch with it?
What we do is, we kind of do what we do on the Mac, is where we have a nightly build of our image. So we build the Windows images nightly. Actually, not nightly. We do it weekly. And we bundle everything in, and that's where with like drivers and a couple of large applications. And then provisioning process will run Chef, which installs Chocolatey, which installs a bunch of packages. So it's very similar to our Mac environment setup.
And then do users get to ingest their new hardware images? Like, it's got a new CPU and new set of drivers, or do you guys ingest that for them?
We're still kind of working that out. Someone's actually rewriting our own imaging environment using PowerShell. And once that's done, that's where we're going to build all that logic into it. But that's where we want to get one day. Yeah.
And then for the Oculus guys, do you guys just give them the built WIM file, and then they just do it on their Pixie servers?
So the way we do it is we have, we want to check it into our get fat replacement, the image itself, and then we sync that across all our distribution points, and we do all of our Windows imaging the backend's actually all Linux, right? And then we distribute that. The same servers that do our Monkey repos serve up our Windows imaging, Pixie boot environments, and the actual image itself.